Yo, I'm Sean Morris. This is your Spreadsheet Doctor. Today we're talking about the three key components of databases and what make databases different from plain old spreadsheets. This stuff is critical to understand if you want to take your spreadsheet into the next level. The first key component is tables. Tables are the backbone of any database. It's where you store your data. Then we've got queries, which are the way that you access and summarize useful information from your tables. And finally, there are reports, which is the way that you present your data. Now that we've outlined these three major components, let's dive into each on a basic level and then a more advanced level. Let's start by talking about the most basic elements of a single table. And this is pretty straightforward. Any basic table has columns, and it has rows. The columns are sometimes called fields, attributes, or variables, and rows are often called records, observations, or tuples. The big point with using tables is that you want to make sure that you only have one data point per cell and don't mix and match data types. This means that you shouldn't merge any cells in a table. We'll talk about this a bit more later. One hot tip for Excel users: when you highlight a range and click on Insert Table, you're creating a special Excel table. This gives you better looking column headers and banded rows, but you also get sorting and filtering buttons and the ability to more directly refer to the data in your table. So the hot tip is to use an Excel table whenever you can. Okay, so that's the most basic level of tables. Now let's talk about a query. Running a query might sound complicated, but that's actually exactly what you're doing whenever you sort or filter a table in Excel. In most databases, a query is run on a copy of a table so that nothing messes with the original table where the data are stored. But even if you were to just filter a table and then copy and paste it into another sheet in a workbook, that would also fit the criteria of a query. Another aspect of queries is that they might roll up data and summarize it in some way. Here we'll generate what's called a frequency table that counts all of the instances of a given city. We'll do that using a unique formula and a COUNTIF formula. Okay, so that wraps up the basic level of queries. Now let's talk about the basic level of a report. Often reports include charts and graphs to track progress on a goal or give an overall picture of performance. Reports are specifically designed to be readable and quickly digestible. This report is a straightforward format that might make sense for a manager who is interested in how much grant money an organization has given out by state. First, we've got blank rows with black fill that separates state grouping sections that have merged cells. And then we've got item totals and merged cells that give us state totals. In general, the problem with reports is that unless you have some automated method for updating them, they can be a pain to make changes to. So for instance, if we wanted to add another donor from Maine, then we'd have to insert a row, type in our data, and then remerge the state cell and the state total cell, and then update the merged state total cell to include the new row. Now this isn't a big deal for one grantee, but when you've got hundreds or even thousands of lines, this can be way more time intensive. One piece of advice that I frequently give to new Excel users is that data should be stored in tables instead of reports. Here is that same grantee's data set in the form of a table with two queries that summarize the data by using a SUMIF formula. This way, if we need to add another row to the table, we don't have to bother merging any cells, and the roll-up queries update automatically. Okay, so now we've talked about the basic level of tables, queries, and reports. Let's get a bit more advanced and talk about how to stay organized when you're working with data from multiple tables at the same time. The key principle that I use when I work with tables is to have a place for everything and everything in its place once. Let's break that down and talk about what each part means. First, if you want to have a place for everything, you need to follow the old rule that you can only manage what you measure. If you don't know how many sales you have in a given quarter, for example, you just won't know how well you're doing. So that translates into the next two guidelines, which are that you should give each thing you want to track its own table. That is, if you want to track orders, you should have an orders table. If you want to track items purchased, then you should have a table with all of the items that each customer has purchased. Next, you should give each table distinct columns. This is just to say that if you want to know what date an order was placed, you should have a whole column dedicated to just recording that piece of information. Again, if you don't have a column or table for it, then you just can't manage it. Next, when I say everything in its place, I mean that now that you've created a space for things, you should put them where they belong. First, for me, that translates to having only one data point per cell. And second, that means don't mix and match data types. You might feel like you're saving space by putting more than one data point per cell in these ways, but separating out data will mean that they'll be much more accessible down the road. Finally, when I say once, What I mean is that you should store your data in a way that you don't make any unnecessary work for yourself. So define the place where you're going to store it, and then make sure you have a consistent way of doing data entry so that you can trust your data are reliable. Next, another good principle in this heading is to give every row a unique identifier that does not repeat. This is key if you want to be able to clean your data and to be able to reference it later. It also helps you distinguish rows if, for example, there are two people with the same name in your classroom. So there you have it. These are the 7 basic guidelines for working with data in tables. In case you're interested, this is part of a way larger topic called database normalization, but we'll leave that for another video. Okay, so now let's talk about tables on the advanced level, and specifically we'll be talking about what these lines that connect the tables are about. So let's say, for example, that you're a real estate agent with a handful of clients and you want to be able to track your phone calls with each client. One thing you could do is to add columns to your table to indicate the time of the call and notes from the call. This might be fine if you only ever have one call per client, but what would happen if you wanted to record multiple calls? Pretty quickly you have a very wide table with blank rows because some clients won't have as many calls as others. In this case, what we'll see is that it's a much better practice to ditch the call columns altogether and remember that each thing you want to track should have its own table. That means one table for customers and another for calls. And as soon as you do this, you've turned your tables into relational tables. And this is the key organizational structure of a huge number of databases out there. And the way the data in your tables are connected is through this non-repeating customer ID in the customers table. The table that has the non-repeating customer ID has what's called the primary key, and the table with the repeating customer ID is called the foreign key because it repeats in that table. This connection between the primary key and the foreign key is called a one-to-many relationship, and the many side is often denoted with an asterisk or an infinity symbol. When a lot of people are getting organized with database systems, it may feel strange to use different tables with different IDs instead of one big table. And with a small enough data set, it may not really be necessary. But with a large data set with multiple things you want to track, you'll find that a relational database with tables connected through primary keys and foreign keys is the easiest way that you can stay organized. So now let's talk about a key issue in relational databases, which is accessing data. This takes us into the topic of advanced queries. Here, I'll show you that if you wanted to see just those calls for Eric Evans, you're essentially running 2 queries at once. One for the customers table where the customer's name is Eric Evans, and another on the calls table where the caller ID is 105. While spreadsheet programs are great for a lot of things, they're not really designed for advanced querying. So what are your options if you wanted to be able to ask questions of your database? In the latest versions of Excel, you can use the filter function. You can specify the filter function to pull in all of the mail survey respondents, or just include an asterisk as an AND operator to include only males who spent more than $1,300 on travel. As useful as the filter function can be, there are some big drawbacks, including the fact that headers and data formats like number signs don't get included in the output. In Google Sheets, you have the much more powerful query function, which uses a modified version of the structured query language, or SQL. Here we can produce the same output, but now with a different function and syntax. SQL is the standard language that's used to write queries on relational databases, so Google was really smart to include a function like this. However, Google's query function still doesn't support join statements, which is the key way that you'll query data from multiple tables at once, so it's still not ideal for larger relational databases. For any queries that are more advanced than what we've shown here, you'll need to use some kind of database interface that allows you to write SQL code, and that can include SQL Server, Oracle, or MySQL. Another program that's older but great for quick and dirty database building is Microsoft Access. Here I'm showing a sophisticated Access database with tons of tables joined together. In this query, we're pulling data from 3 different tables to show the top 10 orders by company. For the advanced level of reports, remember that reports are often produced from queries. Here in Access, we can use a query to format a monthly sales report. Reports will be different in any system you're using, so my advice is to get to know that system and then see how you can play around with it to make your reports come out the way that you want. Otherwise, just download the data into Excel and work with it manually. So that sums up our beginner's tour of the 3 key components of databases: tables, queries, and reports. If you like this video, please be sure to subscribe and give us a like. And if you're interested in getting any of your spreadsheet questions answered for free on YouTube, shoot us a message at info@yourspreadsheetdoctor.com.